Welcome to Verilog Fundamentals. My name is Cameron Kirk. Verilog has a long history, and we're going to be talking about just the base language. So you see, Verilog is actually a subset of something called System Verilog, and System Verilog is more of like a extension to the language. We're going to talk more about this later, so don't worry about it for now. Just keep that in mind. I'm going to teach you the basics you need to write good Verilog. This is the most popular hardware description language ever, and it is one that is still very relevant today. In this module, I will tell you the advantages of Verilog and why it is still in use today. You're going to see some of the core concepts required for understanding Verilog. And this, of course, will help prepare you for how you can design your own custom hardware components. This course covers the fundamentals of Verilog base language and its system tasks and functions. And this course was created using something called Icarus Verilog and Visual Studio Code. So Icarus Verilog is a tool that complies with the IEEE 1364-2005 standard. And don't worry, this standard did come out in 2005, but it is still in use today, and I will explain why later. Visual Studio Code, on the other hand, is a streamlined code editor that allows you to define and run custom tasks for simple development workflows. And I'll show you how to set up Visual Studio Code with a compiler and some other helpful tools that will help you in a very convenient way write code and run simulations all in Verilog. This course is not tool specific. If you're using Verilog or System Verilog, then you can use everything that you hear about in this course. This course will not be exhaustive in its coverage of features in the Verilog-based language. I will mainly stick to features that are commonly used and supported. We will discuss more about different editions of the language soon. Let me lay out for you the entire course and how it will be presented. Starting with context. This module, the first module. From there, we'll move on to tools, which will cover what you need to run Verilog simulations. And then I can introduce the basics of the language, starting with how to print output from a simulation. Verilog is unusual in that it is not meant for creating software applications. It actually allows you to declare and work with data types and entities that represent physical hardware components, known as modules. With the basics covered, we can talk about logic gates and creating circuits based on logic diagrams. Then I will introduce data flow modeling, something that offers a level of abstraction that is higher than gate level. You see, gate level density of modern digital circuits has increased rapidly over the years. You can imagine maybe a circuit starting out with maybe 50 to 100 gates now contains tens of thousands of gates, and it is ridiculous to imagine trying to stay at the gate level for a long time. You do need that higher level of abstraction. And of course, in keeping with this theme, I will then introduce behavioral modeling, which offers an even higher level of abstraction. And these levels of abstractions simply offer the designer a way to focus on the algorithm they wish to implement in hardware, rather than the gates and the ports and all those nitty-gritty low-level details. And if you want to go to the nitty-gritty low-level details, you still can. But I just wanted to lay this out for you. This list of topics doesn't cover absolutely all of Verilog, and that's not my intention in this course. My plan is for you to be able to read Verilog or System Verilog that someone else has written so that you can understand it, and to be able to write straightforward code to cover most of the work required to design a simple digital circuit. You may still need to learn a particular framework or techniques for modeling, simulating, and synthesizing digital designs. And there will be more advanced topics you can learn once you've had experience using this fundamental knowledge. Sometimes people ask me, what is my favorite programming language? And I tell them Verilog. Often, I get confused looks due to Verilog not being a mainstream programming language that we often hear about. And there are rare occasions that someone does know what Verilog is. So I still have to explain to them why it is my favorite language. And I feel like it's because Verilog is maybe a little bit misunderstood or overlooked. I'm not going to get into it. But I wanted to summarize for you some of my reasons, and maybe they'll connect with you. Verilog is a single-purpose language. Some languages try to be general purpose and try to allow programmers and developers to create all kinds of applications on a huge variety of platforms. If Verilog has only one purpose, it better be for a good purpose. Verilog is a language that allows you to define a custom platform at the hardware level. When you define algorithms at the hardware level, you are implementing something that can outperform even the fastest programming languages like C, C++, or assembly programming. And that's what this is about. It's about power and performance. The fastest possible computation, the most control over your speed and your memory use, and that makes it, of course, and not surprisingly, an industry standard. It is the #1 language for hardware design engineers and has been extended by and merged into System Verilog, with the Verilog-based language mostly unchanged in the last decade, aside from a few quality of life improvements along the way. But you may be a little bit nervous. You may be wondering, isn't it hard? Isn't it really hard? Isn't Verilog that language for really smart electrical engineers? And isn't it that language that regular people can't use because it's so hard? Absolutely not. In this course, I'm going to teach you the Verilog-based language. And Verilog is not a language that is really super duper hard and only for smart people. I want to debunk a few myths. First, you do not need to go learn C or C++ first. In fact, people who already know C or C++, there's a chance they might find Verilog a little bit more difficult to pick up and understand. So certainly do not go off on your own and go learn those first. There will not be a significant benefit to do that, so please don't waste your time doing that. On the other hand, though, if you are someone who already knows C, C++, C#, or Java, then this could speed things up for you when you learn Verilog. This is because you're going to be familiar with things like a ternary operator or declaring and assigning variables. Be careful, though, because Verilog statements are executed in parallel, and you might be used to statements that you write being executed sequentially. The thing about Verilog is you have to specify when operations should happen sequentially. You'll be able to pick this up, but I just wanted to throw that out there as an FYI that you're going to be okay. You're going to be okay. It's a little bit of an adjustment. If you're someone who is familiar with Boolean logic, or if you know what an if is and why you might want to test whether something is true or false, then you can absolutely learn Verilog. Verilog applies logic constructs to build and develop circuits. If you understand the truth table for a 2-input AND gate, or a 2-input OR gate, or how the NOT gate works, then you will be able to understand Verilog. And lastly, if you're someone who doesn't know any programming languages yet, then learning Verilog could be a good first language to learn. And while we're talking about Verilog, let's just quickly talk about system tasks and built-in capabilities. So pretty much every language comes with some sort of library. Verilog is no exception. So Verilog comes with predefined gate primitives, system tasks, and data types that provide built-in capabilities right out of the box. There is a string data type for text. You can start out with logic gates without actually having to do anything. They just give them to you, which is great. And there is a register data type for modeling register files, RAMs, and ROMs for memory. And the system tasks provide you the basics for writing to the screen and to or from files. Verilog is a little bit unusual in that it doesn't belong to anyone anymore. So it did start out as a product created by a company, but the language was donated to IEEE in the 90s in order to define a standard for the language. There was a standards committee founded to review the language and how it works and create a document that describes how Verilog is defined. So then we had the Verilog 1995 edition, which was really the first standard. After that, there was Verilog 2001. And then there was a bit of a problem that appeared. You see, the standards committee couldn't evolve the language quick enough to keep up with the industry. The updates weren't frequent enough, and Moore's Law was moving at a rapid pace. So the industry was moving beyond what Verilog offered when it was published into a standard. Companies in the industry took it upon themselves to accelerate the evolution of the Verilog standard, and they created something called System Verilog, which is really a set of essential language extensions to the Verilog base language that improve design verification. In 2005, System Verilog was donated to IEEE, and in 2005 they created the Verilog 2005 and System Verilog 2005 standards. And both of these standards were meant to be used together. Then in 2008, IEEE merged the two standards into one standard known as System Verilog, and the latest standard for System Verilog is System Verilog 2017. Tool vendors work to bring their tools in compliance with the latest standards. And naturally, of course, different tools will have different levels of compliance. Let's go ahead and summarize everything we talked about in this module. Verilog is a very powerful language. You're going to see how this language works in the videos that follow. And by learning it, you're going to be joining an entire industry of hardware designers who managed to learn it themselves. They got past that reputation that somehow it's difficult. It really doesn't have to be difficult. Verilog is very logical and defines systems from the ground up. System tasks perform a lot of work to help you, and they allow you to build your design in simulation and make it easier. And that's fantastic.